young mathematicians. My name is Alyssa Howell, and I'm the Secondary Director for Mathematics in Houston ISD. We had so much fun this school year that we've extended our learning together into the summer. Each week of summer school, we're going to focus on one activity from each of the grade levels. Let's get started.
Hello, young mathematicians. For grade 6, week 3, we want to focus on what you're asked to do on day 4. The activities on that day are focused on helping you complete the I can statement. I can convert between fractions, decimals, and percents using different models. Today, we're going to focus on using strip diagrams and ratio tables. So the activity that we're focusing on is the chart that is asking you to convert between ratios, percents, tenths, and decimals. And I'm going to focus on 1/5. But the process that I use for 1/5 can be repeated with any of the fractions on this table. So let's start looking at our strip diagrams. The first thing that I did was I cut out strips of paper. I really just traced my ruler. And I want them to all be the same length. So you'll notice that I just traced my ruler and I cut them out to be the same length. For me, I made them all 10 inches long, but you can do them any length that you want. And the first part of the table asks us to figure out how I'm going to write 1/5. And so I need to make sense of that 1/5. What does that mean? Well, 1/5 as a ratio can mean 1 piece out of 5 pieces. So I took my strip, remember they're all the same size. I took my strip and I looked to see what happens if I have 5 pieces that fall within this strip. And so I want to look at 1 piece out of the 5. So this is going to represent my 1/5. This is going to represent the fraction that I want to create using different comparisons. So 1/5. The next part of the table asks me to compare out of 100. I want to look at the percent or per 100. So that means that I took my strip, and remember they're all the same length, and I want it to be from 0 to 100 this time because I'm looking at percents. So I started, and I have to be honest with you, I kind of stopped. This got to be really long. This was going to be 100 little slips all the way along. Whew, it was a lot. So I started out, and I was first able to divide this into sections of 10, and then I divided each section of 10 into 10 more little sections. So that when I look to see, remember this is my 1/5 fraction representation, and I look to see how it matches, I find out that it matches 20 little sections. And remember how many are supposed to be on this whole strip? If I had kept going, there would be 100 strips all the way along here. But my portion of it, my ratio of it, only represents or only aligns with 20 out of the full 100. So I can write 20 out of 100. So my ratio of 1/5 or 1 piece out of 5 is equivalent to 20 out of 100 or 20%. Some of you may remember from the school year that we could also write 20 out of 100 as 20%. So that's important because these are the first 2 columns on our sheet for 1/5. So the next column asks us to look at the tenths. So, do you remember? I go back to my strip. My same strip, remember they're all the same. But this time, because it's telling me I want to make the comparison to tenths. So I'm going from 0 to 10. So in this situation, I'm going to divide up into 10 equal sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections. And I look to see where my ratio is representative. Out of the 10 pieces, I notice that 2 of the sections align with my portion of the ratio, 2 out of 10. And so that's how we write that portion. So if we review, 2 out of 10 is equivalent to 20 out of 100, and that's also equivalent to 1 out of 5. So the last column of the table takes a little bit more thinking. We're going to be talking about the decimal representation. So I go back to my strip that's the same size as all the others, but this time I'm going from 0 to 1 because I want the decimal representation. It's easier sometimes for me to think about this like a number line. How can I count from 0 to 1? And so we want to use our decimal system. Remember, our decimal system is based on sets of tens. So I just go from 0 to 1, and I can look at my tenths section again. So if I think about this in terms of a number line, it's a little bit easier to think if I start at 0, this is 0.1, this is 0.2, this is 0.3, this is 0.4, this is 0.5, 0.6, 0.7, 0.8, 0.9, and then I have 1.0 on the end. And so the decimal portion that matches my ratio representation is 0.2 in comparison to the whole 1. 0.2 in comparison to the whole 1. So I would write that in my last column as 0.2. And actually, that kind of makes sense. Don't we refer to that portion of the place value as the tenths? 0.2. It's 2 tenths. Hey, that was what we put in the column before. And these are equivalent to the percentage of 20 out of 100. And it all started with 1/5. So this is what I would put in my table. Now let's look at it in terms of a ratio table, because this was using strip diagrams. So if I use a ratio table, I start out with my ratio of 1 to 5. Now remember that I can use different scale factors to get to different portions, different ratios, so that the proportions are equal. So for instance, what would happen if I multiplied by 2? Now remember, you have to do it to both portions of the ratio. 1 times 2 is 2. 5 times 2 is 10. And look at that. I have my ratio of 2 tenths. I can also multiply by another scale factor. What would happen if I multiplied instead of by 2, but I multiplied by 20? Do you know how much 5 times 20 is? That's right. It's 100. So I also have to multiply by 20 on this side, and 1 times 20 is 20. So I get the ratio of 20 over 100. But it doesn't just have to be multiplication. Ratio tables can also look at division. So let's look at this one. What would happen if, I know. What if I divide the 2, if I divide it by 10. I'll have to remember to divide the 10 by 10 over here for this portion of the ratio too. Well, 10 divided by 10 is real easy. I know that's 1. 2 divided by 10 is a little bit more difficult, but it's 0.2. So that this ratio is 0.2 over 1. Have you seen these numbers before? I bet you have, because they're the ones that go in your table, where we have the ratio of 1/5 is the same as the percent 20 over 100, is the same as 2/10, is the same as the decimal 0.2 over 1. See you next week. Thanks, mathematicians.
Welcome, young mathematicians. I'm Jonathan Denning, Houston Independent School District. I'm a teacher development specialist, and this week we'll be working through grade 7, week 3, and we'll be doing lesson 3. Remember the last few sessions we've used our map, and we're going to do the same thing today. We'll be comparing both equations and inequalities. So make sure you have your paper ready and your pencil. Let's get going. Today's learning targets are to model, write, and solve equations and inequalities using real-world scenarios. Let's say that you're in a restaurant and the bill is $11. You used a $4 discount. You and your 2 friends need to know how much to pay individually. So on the left-hand side, we'll be able to model our equation. On the right-hand side, we'll solve it. Underneath our equation today, we'll draw a number line. And today we'll use our number line to check our work and make sure that our solution is correct. The last step that you and I will take together today to hit our learning target is to draw a graph of the solution. The one thing inequalities and equalities have in common is that when we solve them, we use inverse operations. So the inverse operation of addition is subtraction. So when we think about solving inequalities and equations, the opposite of multiply is divide. In our vocabulary today, an equation will have an equal sign, but an inequality will have an inequality symbol like greater than, less than, greater than or equal to, or less than or equal to. Remember that the greater value will be on the bigger side of the inequality. With our goal to compare inequalities and equations, we'll use a first example of x minus 3 equals 0. We'll write a story that says, if you want to break even in your business and handle $3 in cost, how much do you need to sell? Well, let's make a written solution for this one using those inverse operations. The opposite of subtract 3 is add 3, and that makes our solution 3. To check that, we'll use a number line and then graph it. Now that we have our solution graphed, let's compare that against an inequality. X minus 3 is greater than 0. Notice the difference between the graphs. So what's this all about anyway? Equations and inequalities. Well, let's go step by step through an equation. So what is the cost per plate if the bill is $11 after 3 people eat with a $4 discount? Great question. So first we'll take 3 stones to represent 3x. To represent subtract 4, we'll place 4 stones in a bowl. The equal sign and then 11 stones will finish the equation we'll solve. Now, because the stones are minus, or they're in a bowl, we need to cover them. To get them out of the minus, we'll have to use a match of +4. So this matching pair can now go away. And remember, because it's an equal sign, if we add 4 to one side, we'll add 4 to the other side. Now we have 3 stones on one side and a total of 15 stones on the other. I organize them into equal piles so that now I know that 1 stone is equal to 5. 1x equals 5. So I'm going to make my notes that I first added 4 to each side, and then I separated or divided the 3 x's into 3 equal groupings. So 15 stones divided by 3 groupings gives me that x equals 5, or 1 stone is worth 5. Now let's check our answer using the number line, and then we'll graph our solution. We can see the green line at 11, and we can also see 3x minus 4, and x. Notice 3x is the longest. It's 4 longer than 3x minus 4. We break the 3x into 3 separate pieces to arrive at the conclusion x equals 5. Now for example 2, let's compare an inequality to the equation we just solved. So this inequality is saying we want to make a business profit of greater than $9, but we have costs of $3 and what we're selling costs $4. How many do we need to sell to make more than or greater than 9? So again, let's use 4 stones to represent 4x. We'll place 3 stones in a bowl to represent -3. And then this left-hand side, this 4x minus 3 that you see here, has to be bigger than, has to be greater than 9 stones on the right-hand side. So let's count out 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stones. Remember that if you have a minus, that we're going to need to use a match, a plus match. So +3 will do on the left-hand side, and that will take away the -3. We've matched that pair. But if we do it to one side, we're going to do it to the other. So let's count out 1, 2, 3, and let's put those in the pile. So now we're going to sort into equal amounts the 12 stones we have on the right-hand side. And now we know that we have 4 equal groupings of 3. And so x is greater than 3. Let's sweep these off to the side and record some of the notes from the experiment we just ran. The first thing we did was add 3 to both sides. We said that 4x was greater than 12, and we separated the 12 stones into 4 groups. So that the value of one of those large x stones was greater than 3. What's a number greater than 3? 5, good. 6, 7. All of those numbers will work now for x. That's a big difference from our equation where the only number that worked was 3. Let's put it on a number line. X is greater than 3. Could it be 3? No. It could be 4, it could be 5, so we leave an open dot. On the graph, we also make a dashed line instead of a solid line. Go ahead and shade in the region next to or greater than the x is greater than 3 line. It's time for your weekly recap. On Monday, finish your worksheet for solving equations. Use inverse operations on your independent practice on Tuesday. Finish your solving inequalities worksheets on Wednesday. On Thursday, write descriptions from inequalities and equations. And on Friday, watch your video and finish a very important independent practice.
Wow, thank you so much for all of your participation today. Remember, you can use this video on rewind so that you can use it several times. I can't wait to see you next week for our last session of summer school. Until then, thank you. Goodbye.
Welcome, young mathematicians. My name is Mrs. Lord, and I'm so excited to see you here today. I hope you enjoyed the lessons from Miss Howell and Mr. Denning. Today, we're going to be looking at angle relationships. Remember, you can access all of your lessons through your teacher or through the HISD at home website. All right, let's get started. In order to begin our conversation on angle relationships, we're going to start by looking at two parallel lines that have been cut by a transversal. The first angle relationship that we're going to talk about is corresponding angles. In order to show you what corresponding angles are, I took a napkin from my kitchen and I unfolded it so that when I placed it over my drawing, I could trace one of my parallel lines and the transversal. Once I did that, I simply just cut it so that I could see a little bit better. And what you'll notice is you can see angle 5, 6, 7, and 8 right through my napkin. But you can also see that the line that I drew on my napkin matches up with line M, and the transversal matches up with the line that I drew on top. All right, corresponding angles means that if I take this napkin and just slide it up the transversal, what do you notice happens? Let me do it one more time, and I want you to think about what it is that we're showing. Okay, so here my tracing matches up with line M and the transversal and angle 5, 6, 7, and 8. And when I slide it up, you'll notice it matches perfectly. What does that mean about angle 1 and angle 5? Think about what that means. I think many of you are thinking that that means that angle 1 and angle 5 are the same. Similarly, angle 2 and angle 6 are the same. Angle 3 and angle 7 are the same, and angle 4 and angle 8 are the same. So that means if I know the measure of angle 1, then I also know the measure of angle 5. And we call those corresponding angles. In order to examine the next type of angle relationship, we first have to talk about the exterior and interior section of our parallel lines. So remember that interior means inside. If I talk about the interior of a house, that means inside the house. So our interior area is going to be in between our two parallel lines. Our exterior sections are going to be above and below. Now, there's an angle relationship that we call alternate interior angles. Alternate means what? Same side or opposite? Opposite side. So the alternate is going to be 3 and 6. These are our alternate interior angles. 4 and 5 are also alternate interior angles. Take a look at 3 and 6. Do they look like they are congruent? If you thought they did, you are correct. Our alternate interior angles are also congruent. So angle 3 is equal to angle 6, and angle 4 is equal to angle 5. Now we also have alternate exterior angles, and I think most of you can guess what those mean. It means, again, we're alternating sides and it's on the outside. So 1, angle 1 and angle 8, angle 7 and angle 2. Just as there are alternate interior angles and alternate exterior angles, there are same side interior angles and same side exterior angles. So those are just as they sound. They're on the same side and they're either inside, interior, or outside, exterior. So our same side interior angles would be angle 3 and angle 5, angle 4 and angle 6. Our same side exterior angles would be angle 1 and angle 7, and angle 2 and angle 8. Let's return to our alternate angles. So as I said before, if we trace, I went ahead and traced this on a napkin. If I trace angle 3, you can see that matches up, right? And if I bring it down here to angle 6, you can see that it does in fact match up, which means they are congruent, they are equal. But now let's see if our same side interior angles are congruent. So I traced angle 4. It was quite a big angle. We call this what? Obtuse, that's right. So this is our obtuse angle. And when I bring it down to angle 6, you can see it does not line up. It's much larger than angle 6. And that should be the case because remember that angle 4 and angle 5 are the same because those are alternate interior angles. These two are congruent, which means these can't. But what they do form is 180 degrees. All right, now let's get to the good stuff. Why does all this matter? So all of these relationships are helpful because if you are only given one angle measurement, you can determine the measurements of every other angle based off of that single angle measurement. So let's give it a try. Angle 1 is equal to 135 degrees. Okay, angle 1 equals 135 degrees. Now, using our angle relationships, let's see if we can figure out the value of the other angles. So let's start with our corresponding angles. We know that angle 1 corresponds to angle 5, which means they are the same. So now I know that angle 5 also equals 135 degrees. All right. Now, I also know that angle 5 is an alternate interior angle to angle 4. Angle 4 and angle 5 are alternate interior angles. And we know that alternate interior angles are congruent, which means that angle 4 must also be 135 degrees. Now you'll notice that angle 1 and angle 4 are congruent. They are the same. Those angles are called vertical angles. So vertical angles are formed when two lines intersect and the two angles opposite each other are congruent. So angle 1 and angle 4 are vertical angles, angle 3 and angle 2 are vertical angles. Angle 7 and angle 6 are vertical angles, and angle 5 and angle 8 are vertical angles. But let's get back to determining the rest of these measurements. Now, based on what we just said, in terms of vertical angles, you might notice that angle 5 and angle 8 are vertical angles, and vertical angles are congruent. So we know that angle 8 is also 135 degrees. We also know that angle 8 and angle 1 are alternate exterior angles, and alternate exterior angles are congruent. So that just confirms that I'm correct, that angle 8 is 135 degrees. All right, now looking at our same side interior angles, we know that these add up to 180 degrees. So angle 4 and angle 6, or we could say angle 3 and angle 5, have to add up to 180 degrees. So that means that if I do angle 5 plus angle 3. That adds up to 180 degrees. Let's substitute 135 plus angle 3 equals 180. I'm going to subtract 135 from both sides. 135 minus 135 cancels out, is 0. So angle 3 must equal 45 degrees. All right, so angle 3 equals 45 degrees. I know that angle 3 and angle 6 are alternate interior angles and they are congruent, so this must also be, angle 6 must also be 45 degrees. I know that angle 6 and angle 2 are corresponding angles which are congruent. And finally, we learned that angle 6 and angle 7 are vertical angles, which means they are congruent. We could have also pointed out that angle 3 and angle 7 are corresponding angles and they are congruent. And we have now identified the measure of each angle with only having one piece of information, and that's why knowing angle relationships is beneficial. Thank you so much for joining me today. I look forward to seeing you again at this time next week. Take care.